Let's discuss a question from fluid mechanics. So basically you have a siphon and then we need to find out the minimum absolute pressure happening at the siphon. So first what we do is we apply a Bernoulli's equation between 1 and siphon. This is the location where we get the minimum pressure. So first we apply between 1 and A and then see what happens. So P1, Bernoulli's equation is P1 by rho g plus V1 square by 2g. So we are applying between 1 and A, and this is my reference for my potential energy calculation reference datum. Okay, plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Okay, so P1 is something which is atmospheric pressure, so we'll just use 101 kPa, that is given, and this is 9.8 into 10 power 3. V1, well, this is, we assume that is a very large, so V1 is 0. Z1 is the height, which is nothing but from the reference it is 7, because this is 1 and this total is 8, so from reference this is 7. P2 is something which we got to calculate, PA actually, this should be PA. Okay, PA by rho g, which is 9810. I have just multiplied with 1000. V2 is, there will be some velocity of the flow in the pipe which we don't know, and Z2 is basically 8. So now in order to get the pressure which we want, we need to get the velocity, because everything else is known. We need to get the velocity. So this is our equation 1. We'll come back to this. So how do we get the velocity? So what I'll do is apply one same Bernoulli's equation between 1 and this section, which is 2. So the velocity of the flow is same in the pipe. So at A, whatever the velocity is there, okay, that is the velocity at 2 also. So we'll apply between 1 and 2 the same equation. So P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Now we know that P1 is atmosphere pressure, P2 is also atmosphere pressure. So P1 and P2 cancel on both sides. V1 is 0 because we assume it's a larger tank on the left side. So left side we get only Z1, and the right side P1 P2 gets cancelled, so P2 square by 2g plus Z2. So this you will get, Z1 is basically 7 and Z2, so Z1 is basically the total height, which is nothing but 7 of the section 1, V2 square by 2g, and Z2 is 0 because the height of section 2 and the reference level is also at the section 2. So what we get, V2 is root 2gh, which is 7, root 2g Z1, which is 7, and so when I calculate I get 11.7 meters per second. So this is 11.7 meters per second. So I come back to, now I use the equation 1, substitute 11.7 here, and so the combined equation will be 101, okay, by 99.81 plus 7 is equal to PA by 9810, okay, plus V2 square, so this is 11.7 square. So we are basically using again the equation 1 and substituting whatever we have plus 8. So when I calculate this value is 22.7. Remember, this is the absolute pressure, 22.7 kPa. So from 101 the pressure has come down to 22.7 kPa, and that sometimes if this pressure is less than the vapor pressure, so you may have cavitation or the local boiling happening there. So that is the thing. So that's why when you design a siphon, that is very important. So 22.7 is the value here, 22.7 kPa. Thank you.